Hello and welcome. This is tutorial number 25. I'm Joshua Clymer, and my partner in this project is Tristan Taylor.
Hello.
Now, our computer science teacher gave us the task of creating a messaging app, and we took that assignment a couple steps further. One with asynchronous communication, so one person can send something and then you don't have to wait for a reply. It's just like a normal texting application. The second way is we implemented the industry standard encryption methods, AES and RSA, with public and private keys, all of that. So, Tristan, why don't you go a little bit more in depth with the encryption?
Thank you, Josh. So the encryption written is actually, I actually packaged it up all into this neat little library I made called CipherCrypt. It's built on a simple concept. All you have to do is pass a certain method called parse message, the message from the other client, and it automatically handles all the encryption. And it simply tells you whether or not that's a message from another client, or it tells you if that's some text that you can decrypt as something that the other person said, or a message that actually needs to be sent back to the other client because it's part of what's called the handshake at the beginning. The handshake is where the key exchange happens. An interesting problem in computer science and security is the fact that the internet is not totally secure. A lot of hackers can actually see messages that you send across the internet. So how do you send messages between two people in a secure way? Well, you can use encryption, but sending the keys is insecure. So in order to send the keys, we actually use an algorithm called RSA, which encrypts and decrypts in a different way. It's very special. It's very special using prime numbers, such that when you encrypt the data, you can't decrypt the data using the same method you used to encrypt it. Only the person who sent you the key to encrypt it with can decrypt the data. AES is a different kind of algorithm that works many, many times faster than RSA. However, it encrypts and decrypts using the same algorithm. So you need to be able to share the keys securely. So essentially what happens is an AES key is generated by one party and an RSA key is generated by the other. The RSA person sends their RSA key over, and the AES person encrypts the AES key using the RSA key and sends that back. That way, both of the keys are kept the entire AES key is kept completely secret, and both parties can share it without problem. Now I'm going to hand you over to Joshua to explain how the asynchronous messaging works.
All right. So, if you are new to networking, you have two parties in any kind of communication. You have the server and the client. Now, the server is the one who tells the world, okay, I'm listening at this port, right? Or they're the one with the ears, right? They're listening. And then it's up to the client to initially reach out and make a communication with that server. And there's this thing that happens between the client and server called a handshake. And that basically says, okay, I'm sending you something, client receives it, and that's what happens here right at the beginning. So we agree on a certain port, and you have the handshake, and now you have this server program listening, and then you have a client program that's sending, and these are two separate processes that need to happen at the same time. And humans, right, we multitask, or we try to all the time, right? And computers can multitask as well, and it's something called multi-threading. So multi-threading in Java is pretty simple. You have a class called thread, and so you say class receive extends thread, and that allows this to be sort of its own bit of code, and then you can apply the method run to it, and then you can start this program. And then you can also create another class called send2 here, and it is also a thread, and you can run it completely separately. So then you could potentially start the server and then you could start the client. And then they both are running simultaneously. So first thing we do, let's find main here. Okay, first thing we do is we specify who's the server and who's the client, because one person has to be initially the server, then the one person has to be the client. And then what we do is, then we run either the server program or the client program. So say you're the server. So we're going to initiate a socket here, and we're going to start listening on this port 1337. And you have other programs that are doing the decryption and encryption. The handshake happens on this line, I believe. All right, so then now when they're connected, all right, so then you have the server listening in, and now it's up to the client to send a message on the same port. And then it keeps going back and forth like that. So the server's always listening, the client always has the opportunity to send. All right, so Tristan, can we demonstrate this code?
So if we could, we would totally demonstrate this code using two separate computers communicating over a network. However, we're having a little bit of trouble screen recording both computers, so instead we'll just do it with the one computer, and we'll run two instances of the program. The first thing we're going to do is we're going to go up to our main, and we're going to make sure this Boolean serve, which is used to indicate whether or not you're the server, is set to true. Now that we know it's set to true, we can run the program. And if we wait a moment for it to compile, please ignore the yellow text. We can see now that it's waiting for someone to reply. That's what this is. Now we can comment out the serve equals true line, which now means that Boolean serve is set to false, and run it again. This will start the client program instead. Now if we run the client program, you'll see that the first thing that it does after establishing a connection is it says that's initiating the CipherCrypt handshake. That's the whole encryption thing happening. This is actually the handshake that it uses to initiate the encryption. Once the encryption is successful, it says connection established. If we go back to the server, you can see that the server noticed that somebody connected, and once it was connected, it lets you know that the connection was established. Now we can easily chat between the two clients. Like I can say, hello. I can say, hello world. And that'll appear on the client if I scroll down. But of course, it's not very useful if I can only send messages one way. So I can definitely send messages both ways. So if I say hi there on the client, you can see it show up on the server. The really interesting thing here is I don't have to wait for the other person to say something back to send a message of my own, unlike certain other chatting programs. I can send as many messages as I want of just random text, and they will all appear on the other side, and I can do the same over here. It doesn't matter how many of these I'm sending, because these are all set up using the asynchronous chat implemented by Joshua.
All right. Thank you for watching our tutorial video. This is an application we use all the time, texting, but it is quite a learning experience to actually try to implement our own. All right, thanks for watching. See you next time.